The use of big data in healthcare. Big data refers to the large and complex data sets that are difficult to process and analyze using traditional data processing techniques. This data can come from a variety of sources, including social media, medical records, financial transactions, and more. In recent years, big data has become increasingly important in the field of medicine, where it is being used to improve patient care and outcomes. One way that big data is being used in medicine is through predictive analytics. Predictive analytics involves using algorithms to analyze large data sets and identify patterns that can be used to predict future outcomes. For example, predictive analytics can be used to identify patients who are at high risk of developing a certain disease, allowing doctors to intervene early and potentially prevent the disease from developing. Another way that big data is being used in medicine is through precision medicine. Precision medicine involves tailoring treatments to the individual characteristics of each patient, including their genetics, lifestyle, and medical history. Big data is critical in precision medicine because it allows doctors to analyze large data sets and identify patterns that can be used to develop personalized treatment plans for each patient. Big data is also being used to improve clinical trials. Clinical trials are essential for developing new treatments and drugs, but they can be expensive and time-consuming. Big data can be used to identify potential participants for clinical trials and help researchers design more efficient and effective trials.
Big data classification. Classification is the procedure of categorizing data into distinct groups based on specific attributes or features. It is referred to as classification and is a fundamental aspect of data mining, which encompasses forecasting the class of newly observed data by employing modeling techniques. Classification plays a pivotal role in the processing of big data and is intimately involved in the discovery of knowledge. The importance of classification in big data. Classification is an essential component of big data analytics, facilitating knowledge discovery and enabling intelligent decision-making. Given the vastness and complexity of big data, the absence of effective classification would render the task of extracting information akin to searching for a needle in a haystack. Classification is indispensable for systematically analyzing the immense volume of data by categorizing it into appropriate classes. This process allows for the creation of precise models or descriptions for each defined class, utilizing the distinct data features associated with them. Challenges in big data classification. Big data classification poses significant challenges due to its intricate nature. Handling big data is far from simple, given its multifaceted properties. The same level of complexity applies to big data classification, which presents numerous hurdles primarily stemming from the inherent characteristics of big data. Big data classification approaches. Typically, the following two approaches are followed for big data classification. Supervised classification approach calls for learning classification logic under directed supervision by means of understanding the patterns in a known labeled dataset. This classification approach takes the large volume of data called the training data set as input. To understand the classification rules for categorizing data into the given classes, data analysis is performed on the dataset. The classification rules which are learnt in this process are based on the features or attributes of each element of a class. Since in this classification approach, the set of possible classes is known in advance, it is also known as directed or predictive classification. Unsupervised classification approach calls for learning classification logic from a set of unlabeled data, that is, here the class labels are unknown, and the training sets are not along with predefined class labels. In other words, the set of possible classes to which a datum will be classified is unknown in prior. After classification, the classes are given names. Hence, this approach is often known as clustering. The classification is carried out by drawing the comparisons between the features of data. This approach is useful when features or attributes are unknown, and therefore, the unsupervised classification techniques are often said to be as descriptive or undirected. Big data analytics. Big data analytics, to be efficient, is an advanced form of analytics. As a consequence of this, it incorporates compound applications with elements such as predictive models, statistical algorithms, and what-if analysis powered by high-end analytic operations. Data analytics can be thought of as the extraction of insights and actionable knowledge from big data. Insights from data can be achieved by making use of the hypothesis formulation that's based on inferences gathered from experience and seldom striking correlations among variables. There are four kinds of data analytics. Descriptive analytics: in this type, all prior data is accumulated and organized handily as bar graphs, charts, pie graphs, maps, scatter diagrams, etc., to get a simple visualization that provides insight into what the data implies, generally known as a dashboard. Predictive analytics: as the name suggests, the system predicts based on the information gathered as to what is expected to happen next after it extrapolates the available data. The various tools that are used for extrapolation are time series analysis using statistical methods, machine learning algorithms, and neural networks. Discovery or exploratory analytics: this kind of analytics is used to discover unexpected correlations between parameters in a compilation of big data and provides an additional chance for making serendipitous discoveries and accumulating insights from the collection of data. Prescriptive analytics: this refers to the utilization of accumulated data to identify and recommend optimal solutions for existing issues. In the context of a hospital, prescriptive analytics can provide valuable insights and guidance to improve patient care and operational efficiency. For example, by analyzing historical patient data, treatment outcomes, resource utilization, and staff schedules, prescriptive analytics can suggest specific actions to enhance patient outcomes, streamline workflows, allocate resources effectively, and optimize the hospital's overall performance.